Maasmeier. I am one of the researchers involved in project C1, where we investigate solid fuel combustion of different solid fuels in different atmospheres, air and oxy-fuel atmosphere. And the data we measure in this facility serve us to better understand the mechanisms which are underlying in these flames, and they also serve the project C2 to validate the numerical model which they develop. Here I'm standing on top of the chamber. The burner is introduced here. And we have the combustion gases which are guided to the top section of the burner. And in the back you see something which is very specific for this facility, is that we can vertically displace the burner with this hydraulic system here.
Hi, my name is Diego Sabrodiak. I'm one of the researchers involved in project C1. And behind me is the combustion chamber with the observation ports that we employ for measurements, direct measurements in the flame, either with optical means or with probe means. And through these windows, we can employ our measurement techniques or the measurement techniques from other projects such as B4 or B5.
Particle image velocimetry from B4 was used to determine local particle velocities, while tunable diode laser absorption spectroscopy served to non-intrusively evaluate line-of-sight species concentration.
This is our LDA system mounted in front of one of the observation windows that we commonly use to measure and determine the velocities of the flows inside the combustion chamber and the flames.
By crossing focalized laser beams at their focal distance, we can form a measurement volume of less than 0.1 cubic millimeter.
Besides the optical windows, we also have the possibility of measuring and studying the flame by means of intrusive probes. And for this purpose, we have a system that allows us to manipulate and traverse these probes into the combustion chamber.
Different probes serve to measure different parameters, such as local particle or gas temperature or local gas concentration.
Hello, I'm Roy Özer. I'm working on shadow Doppler meter, STV in short.
For the development of the STV system, we use normal LDV optics, which form a measurement volume, and by subsequent lens system, which collimate and expand the laser beam, we then project the measurement volume onto photodiodes.
STV allows me to measure the particle size and particle velocity simultaneously. STV is based on the concept of capturing the shadow of the particle during its transition in measurement volume.
I personally like a lot about Project C1, the fluid dynamical part, with all the complexities that are part of this very specific problem. Another nice aspect is that besides the very intense measurement campaigns, the job is quite flexible and allows me to have family and a full-time job at the same time.
I like the project because we are working on a flame, which is a combination of fluid dynamics, heat transfer, and reaction kinetics, the subjects that made me decide to be a researcher. Also, I always find working on a multidisciplinary phenomenon more meaningful and more challenging.
I like the project because it covers everything that a mechanical engineer like me loves. For example, we get to work with a lot of advanced equipment like lasers and detectors. And then we get to study this flame, which is a very complex and extreme physical process.